Okay guys, welcome back to my channel. Now today we'll be discussing the topic projectile motion. Okay, now quickly, what is projectile motion? As written on the board, it is a parabolic motion of an object in a trajectory pathway. Okay, the motion forms a parabola while the pathway is what now? A trajectory. Okay, just for clarity's sake or for knowledge sake, every object that undergoes projectile motion is called a projectile. Okay, and now we said it exists in both the horizontal in the x and the what now vertical y. So we can say it is a two-way motion or a two-dimensional motion. Now how do we mean? On the board is a diagram. Now this is the y-axis and this is the what now x-axis. You launch an object with u as the initial velocity inclined at an angle theta to the horizontal. From vectors we can resolve this u to uy or to ux. How do we do that? Whenever you are closing an angle, you use cos, close for cos. When you are spreading, you use sine, spread for sine. So taking u to ux, we'll be closing the angle theta. So ux, we can quickly say, for the first start, we can quickly say that ux must be equal to u cos theta because we are closing the angle. However, uy should be equal to u sine theta because we are spreading the angle. So the initial velocity can be resolved into the horizontal ux and the vertical component ui. Now moving on, as the object leaves this path, it acquires or reduces what now? Velocity. It reduces what? Velocity. So if you are asked to find the velocity at any other point after the launch point, how then do we do that? The diagram on the board also explains. Now you have v here. Remember, the velocity is tangential to the pathway, okay, like a curve. So we have v here. Now this v can also be resolved into vx and vy. Okay, so from Pythagoras theorem, you recall that this v is the hypotenuse. So we can say v should be equal to square root of vx squared plus vy squared. I'll say it again. V should be equal to what now? Square root of vx squared plus vy squared. And if you're asked to find the angle at which v makes, we're going to say tan inverse, okay, of vy over vx. Now, mind you, I did not say uy or ux. I said v because uy and ux is at the beginning. Once you've left the projection plane, you don't have u anymore. You now have v altogether. Now, moving on quickly, the time it takes this object to move from here to this maximum height, we call that time to reach maximum height. Okay, and by mathematics, the time from here to here is also the same as from here to the ground. So if here is small t, we also have here a small t. So the total time of flight becomes t plus t, which is 2t. So we can say the total time it takes this guy to leave the ground and fall back to the ground becomes what now? 2 times the small t. What is big T? The time of flight. And what is small t? The time to reach maximum height. Okay, now moving on, the next thing to do is to bring out the formulas, or rather the equations of motion, which I have taught in the previous video under motion part 1, part 2, and part 3. So please do well to go back and watch those videos carefully. Now, we're going to treat the x motion first and foremost. Let's look at the x motion for a projectile motion. Now, just recall the first equation of motion says vx equals to ux plus or minus at. Okay, now for horizontal motion, for a projectile, okay, the acceleration is always equal to 0. I'll say it again. For the horizontal or x motion under a projectile motion, there is no horizontal acceleration, meaning there is no change in velocity. Let's see that. So if a becomes 0, meaning everywhere here becomes what? 0. So we then have vx to be equal to what now? Ux. Now this explains that the final velocity in the horizontal must be equal to the initial velocity in the same horizontal. So there's no change in what now? Velocity along the horizontal plane. Recall we said ux was u cos theta. We're going to put that here. So this becomes u cos theta. Okay, so this is the first equation you must note for the horizontal part of a projectile motion. Okay, now the second equation of motion will not matter here. Why? Because we get this first guy back. So let's keep that. Now the third equation of motion that says x or distance equals to uxt, okay, plus or minus half at squared. Recall a is 0, so everybody here becomes 0. We are left with x to be equal to what now? Uxt. Now we're going to modify that equation. Now the x is now turned to arrow. What is arrow? Arrow is called range. Range, also called the horizontal distance. I'm going to say arrow is equal to uf. Now, since I'm taking the time from the start to the finish, I'm going to use big T, okay, because I'm dealing with the entire time taking. Now, recall what ux is. Ux is u cos theta. So you can say this is also equal to u cos theta times t. Now, this is the formula to find the range of a projectile motion. Now, quickly, that will be all for the horizontal part. Let's look at the vertical part. Okay, so therefore, the y motion of a projectile. The first thing to note is that the a becomes equal to g. Okay, the a becomes what now? Equal to g. What is g? G is the acceleration due to gravity, because on the y you are being acted upon by gravity. Again, the first equation of motion, which says vy equals to uy. Now, since we are going up, we'll be using a negative g. So minus g, I can just say t for the entire motion. Okay, now recall again that uy is u sine theta. So we can say this becomes vy equals to u sine theta minus gt. This becomes the first equation for the vertical motion of a projectile. Okay, we're going to recall something that we learned under motion, which says that at maximum height, Vy must be equal to 0. When you throw an object upward, it gets to a point above the ground where it can no longer go further. That point is called maximum height, meaning it will now return back to the thrower. So at that point, the velocity stops to exist, meaning V there becomes 0. But now it is a vertical part, so it's Vy. So at maximum height, okay, at maximum height, okay, Vy equals 0. So let's put this value into this equation. We're going to have 0 equals u sine theta minus g. Now watch. Since we are dealing with maximum height, the time we are going to use will not be the total time, but the small t, the time to reach maximum height. We're going to say small t. Okay. Now let's make small t the subject of the formula. We're going to bring gt over this direction. We're going to have gt to be equals u sine theta. Now divide here by g and here by g. So g takes out g. We can say the time to reach maximum height becomes u sine theta over g. This is the formula which I'm sure you should remember from your secondary or O-level days. Now, since you know the time to reach maximum height, it means you can now find the time of flight. So you can quickly just say the time of flight becomes 2u sine theta over g. This is the time of flight. Now, moving on to number 2. Now, the second equation of motion says Vy squared equals to Uy squared plus or minus 2gh. Let's put that down. Vy squared equals Uy squared. Now we're using minus y, I'm going against gravity, minus 2gh, minus 2gh. Okay, so now again, we all know what Uy is. It is u sine theta. But now we're having it squared here. We're going to square every parameter. So we're going to say Vy squared equals u squared sine squared theta minus 2gh. This formula is applied. But now again, just as we did in this case, we're going to do that again here. So again, recall at maximum height, Vy equals 0. Now, since Vy equals to 0, we can then say, what do we have next? Okay, so put that value into this expression. We're going to say 0 squared becomes 0. So we have 0 equals u squared sine squared theta minus 2g. Now remember, at maximum height. So our h changed to the h max, the maximum height. Let's bring this over to this part. We're going to have 2g h max, okay, becomes equal to u squared sine squared theta. Dividing both sides by 2g, dividing both sides by 2g, so 2g takes out 2g, we have maximum height, so be equals u squared sine squared theta all over what? 2g. Formula for maximum height.